Okay, so hello and welcome again to Engineering Physics, and for this video we would now be discussing about free fall. So free fall is actually a type of rectilinear motion. So with that being said, so for free fall it is to be a motion that is to be along a straight line. So it is just that, unlike in our previous example, our free fall is now to be directed vertically downwards. So for free fall, you would now be hearing the term free falling body a lot. And when we say free falling body, so these are to be the bodies that are actually falling, so no pun intended. So falling under the sole influence of gravity. So in Filipino, nahuhulog siya kasi nga may gravity. Di ko lang alam yung Tagalog ng gravity, pero yun. So that is for your free fall. And speaking of gravity, so just like what was discussed in our classroom the last time, so for our gravity G, so your G is actually the acceleration due to gravity, and we will be making use of the value negative 9.81 meters per second squared. So as you can see, it is now to be negative because it is to be directed downwards. So for our sign convention, so for your y, so y is to be positive if it is to be measured above the starting point, and negative if it is to be measured below the starting point. So in other words, if it is up, it is positive, and if it is down, well, it is to be negative. So positive and negative. So same is true with your initial velocity and your final velocity. So if your velocity is to be directed upwards, it must be positive. And if it is to be directed downwards, it is now to be negative. So the formulas that we will be making use here is very similar with our uniformly accelerated motion. It's just that for our value for your acceleration, it is now to be replaced with gravity. So there. Okay, so proceeding, let us just have an example. So in this particular example here, which is very basic, so it is said here that an object was dropped vertically downwards from a ledge 50 meters above the ground. So A, how much time will it take to travel to the ground, and with what velocity will it strike the ground? Okay, so suppose that this is to be your building, and let's say that the object was dropped at this particular ledge, so it at this particular position. So I will just be changing the color. So let's say that it is to be at this level here, and let's say that this is now to be 50 meters. So let's say that this is now to be 50 meters. Okay. So with that, guys, of course, it is said in the problem that the object was dropped at this particular portion. So with that, I will just be writing all the knowns. So the height, or y, is now to be equal to 50 meters. And what about for our initial velocity? So as stated in the problem, so the object was dropped. So by dropped, hindi niya hinagis pababa, literal na binitawan niya lang. So that is to be in Filipino. So in English, well, it is basically just drop. So with that, our initial velocity is now to be 0 meters per second. And as for its acceleration due to gravity, so this remains to be constant since this building here is on Earth. So our gravity, or the acceleration due to gravity, is now to be equal to negative 9.81 meters per second squared. Okay, so with that, let us now solve for the problem. So for the first problem, how much time will it take to travel to the ground? So what that means is that how much time will it take for this particular object to travel 50 meters, because 50 meters is to be measured from the starting point up until the ground. So time is to be unknown. So if you would be looking at this formula, so I suggest us using this particular equation here, because x is already known, vi is to be known also, so vi is equal to 0. So for your time, that is to be the one unknown, and as for your gravity, that is to be constant, negative 9.81. Okay, so with that, so our y, so y is now to be equal to VIT plus AT squared divided by 2. So with that, for your value for your y, that is to be 50. But take note, if this is now to be your initial position and it is going downwards, our distance y should be negative since once again, it is going downwards. Okay, so this is now to be equal to VIT, but since our initial velocity is now to be equal to 0 meters per second, so 0 meters per second times time. So plus, so this will just simply cancel out because that is to be equal to 0 plus. So what is now to be the acceleration? So basically, that is now to be g. So basically, that this is to be g. And for your g, that is now to be equal to negative 9.81 meters per second squared. Okay, so there times t squared divided by 2. So solving for time, we would now be arriving at an answer of, so as you can see in the calculator, so I would be transposing it here. So negative 50. So from negative 50, I would now be multiplying 2 because 2 would go to that place. So times 2. And I will be dividing negative 9.81. So negative 9.81. But take note that our t is squared. So we would now be getting the square root of it. So square root of answer. So 3.1928 seconds. So this is now to be our answer here. And as for, if you would now be resolving for it via shift solve, so negative 50 is to be equal to negative 9.81 divided by 2 times alpha x squared. So our answer here is now to be equal to negative 3.192725 or 3.192754. Okay, so why do we have two answers? So we have two answers because this is to be squared. So if you would be getting the square root of a certain object, their answer should be positive and negative. So dalawa talagang lalabas yan kapag square root. However, in our case, our time should be positive because we wouldn't be considering time as a negative value. So yan na yung answer mismo natin ngayon. Okay, so with that, of course, our time is to be equal to positive 3.1928. So this is for letter A. But what about for letter B? So for letter B, so with what velocity will it strike the ground? Okay, so for your VF, so your VF is basically your VI or your initial velocity plus the acceleration due to gravity times time. So if you would now be going back to your formula, so it is basically this one. And if you do not want to make use of that one, so you can also make use of this particular equation here. Okay, however, in my previous number, I have already solved for this time here, so I would just be making use of this. But if you would be making use of this and this, your answer should be the same. Okay, so with that, so VF is equal to VI plus GT. However, your VI is now to be equal to 0. So with that, so VF is equal to 0 plus, so gravity, but take note that your gravity is now to be a negative value, so negative 9.81 meters per second squared times t. So your t is now to be equal to 3.1928. So 3.1928 seconds. So with that, the value for our VF is now to be equal to, so negative 9.81 times 3.1928. So negative 31.3214. So negative 31.3214 meters per second. So as you can see that our VF is to be a negative value because it is to be directed downwards. Kasi nandito naman yung VF mo, pababa siya. Thus, it is to be having a negative value. Okay, so if you are to resolve for our VF using this particular equation here, so using this, so pwede naman. So let us just do that. So alpha x squared, so this is now to be your VF. So this is to be equal to VI, and our VI is to be equal to 0. And as for our 2GY, that is to be 2 times, ayaw. So 2 times negative 9.81 times negative 50. So shift solve, and our answer here would be 31.3209. So as you can see, they just differ in 2 decimal places, but they are essentially the same. Okay, so moving forward. So same problem, but what if instead of just dropping the object, so once again, instead of just dropping the object, let's say that the ball was thrown vertically downwards with a velocity of 5 meters per second. So basically, same approach. So I would just be copying all of this. So same approach, it is just that our VI would now be equal to 5 meters per second. As seen here, so I would just be erasing all of this. So yung VI natin ngayon meron na. So VI is equal to 5 meters per second. So if you would be rereading the problem, you would be arriving with this given. So once again, same old, 50 meters. So 50 meters height for a moment. Okay, so once again, same distance, 50 meters. It's just that for your VI, the ball was initially thrown at 5 meters per second. So for 5 meters per second, VI na yan, and etc. So with that, for our A, so how much time will it take? So we can make use of our equation earlier. So pwede naman tayong gumamit din ng iba, but in my case, I still want to use this equation. So I want to use, let's say, this particular equation. So same old. So I would be making use of this equation. Okay, so for your value of A, for the value for your time, so for question A, so Y is to be equal to VIT plus AT squared divided by 2. So substituting known values, that your Y is to be negative 50. So I have accidentally erased our figure here. So once again, our our distance is to be 50 meters, but it should be negative because it is going downwards. So so negative 50 meters is equal to VIT. So for your VI, take note that it is to be thrown vertically downward with a velocity of 5 meters per second. So with that, negative 5 meters per second times T plus A. So what is to be the acceleration? And our acceleration G is to be negative 9.81 times, of course, time squared divided by 2. Okay, so with this, guys, we would now be simplifying this equation. So that is now to be equal to, so negative 9.81 divided by 2 T squared minus 5 meters per second T plus 50. So what I did was just that I have transposed this to the other side and reversed the equation. So pinagsama-sama ko lang sila in one side. Okay, so with that, I can rewrite this equation here by what is to be 9.81 divided by 2. So that is to be negative 4.905 T squared minus 5T plus 50. This is to be equal to 0. Okay, so there. The next thing that we will be doing is that we will be solving for T. But as you can see, for the value for your T, it is to be in a quadratic equation. So it is in a quadratic equation. So if you are to deal with quadratic equation, you must use quadratic formula. So suppose that you would be having an equation of ax squared plus bx plus c is equal to 0. So from your algebra, the quadratic formula means, for you to solve for the value for your x via quadratic formula, that is basically negative b plus minus the square root of b squared minus 4ac divided by 2a. So that is now to be your quadratic equation. So with that, So we would be having two answers for t. So that is to be t1 and t2. So for your value for t1, so looking at the calculator to your left, so suppose that this is to be negative b, so alpha b, plus square root of b squared minus 4 times a times c divided by 2a. So negative b plus minus square root of b squared minus 4ac. So it would be substituting b as what is to be the value for b, so that is to be negative 5. So what is to be the value for a, so that is to be, by the way, this is to be your b, this is to be your a, so that is to be negative 4.905. And what is to be the value for your c, so that is now to be 50. So 50. So with that, my first answer is to be negative 3.7429 seconds. So what about for the second one? So what I will be doing is that I would just be changing the positive sign here into negative. And my answer here is to be 2.7235 seconds. So with that, since we will not be considering a negative value for our answer, since this is to be in time, so we would now be getting rid of this, and this is now to be our final answer. Okay, so another tip on solving for quadratic equation, if you would be having a calculator that is very similar to my calculator on your screen, just go to mode 5, so mode equation, so mode 5, then 3. So this is for quadratic equation, so 3. So the calculator would now ask you what is to be the value for a, b, and c. So just substitute these values here. So this is now to be a, this is to be b, and this is to be c. So those are to be negative 4.905, negative 5, and 50 respectively. And he will now give you your answers for x1 and x2. So for your t1, so that is to be 2.7235. And for your t2, that is to be negative 3.7429. So it is to be the same with what we have been solving a while ago. So with that, once again, our answer is to be this one. Okay, so I will just be erasing all of this. Okay, so moving forward, so that is for letter A. But what about for letter B? So for letter B, this is fairly basic. So same old, same old. So for your final velocity, since we already know the time, this is basically VI plus AT. And our acceleration should be the acceleration due to gravity. So with that, VF is to be equal to VI, and VI is to be 5 meters per second directed downward. So that is to be negative 5 meters per second. So plus, so what is to be our gravity? So this is now to be negative 9.81 meters per second squared times time. So times t, and our t is to be 2.7235. So 2.7235 seconds. So with that, our final velocity is to be, so going back to our comp mode, so negative 5 plus negative 9.81 times 2.7235. So this is now to be negative 31.7175 meters per second. So this is for our example. Okay, so let us have this last example for this video. And in this example, so a ball is thrown vertically upward from the roof of a building. So it just misses the roof on its way down and passes a point 30 meters below its starting point 5 seconds after it leaves the thrower's hand. So air resistance may be ignored, and these are to be the questions. Okay, so before answering any question, let us first draw the figures for us to better visualize the problem. So it is said in the problem that a ball was thrown vertically upwards from the roof. So suppose that this is now to be your ball at the edge of the roof, and it is now to be thrown vertically upwards. So let's say that this is now to be its motion. And of course, once that this is now to be thrown, of course, it must also go down because of gravity. So, in this line of motion, meron siyang velocity, then its velocity would now be decreasing because the acceleration is acting opposite to this direction. So, up until this point, whereas your v, so your velocity at every point, at the top of your free falling, of your particle here is to be equal to 0 meters per second. So, take note of that, guys. So, at the highest peak, at the peak of an object that is to be thrown upwards, it must always be equal to 0 kasi pababa na yan. So, from a positive velocity that is going upwards, so at a certain point, at its peak, its velocity would now be equal to 0, and after that, its velocity would now be negative. So, there. So, it is also said here that it misses the roof on its way down. So, what that means is that if it would fall down, of course, it would not hit the roof. So, with that, its line of action is now to be here. So, take note, guys, na hindi naman siya umurong. So, its position did not change. It's just that, so for example, that this is now to be your first line of motion. On its way down, it is still here. So, dito pa rin siya bababa. It's just that I would be drawing it here for us to better visualize the problem. But take note that its position did not change. So, with that, so this is now to be, let's say, your figure. So, it is said here that it passes 30 meters below its starting point after 5 seconds after it leaves the thrower's hands. So with that, measuring it from your initial position downwards, this is now to be equal to negative 30 meters. So this is now to be negative 30 meters. Okay, so for the first question, we are to determine the initial speed of the ball. So for A, Vi is to be the one unknown. Okay, so with that, I would just be making use of this equation. So Y is equal to initial velocity times time plus AT squared divided by 2. So I will be making use of this equation because I already know the value of Y. So your Y is to be the distance from your initial point up until, of course, this point. Kasi yun naman ina-analyze natin. So with that, this should be negative 30. So it is negative because it is going downward. So negative 30 meters is equal to Vi is to be unknown. And as for your time, it is indicated here that it took 5 seconds to reach this position. So from going up until going down up until this position, it took 5 seconds. So our time is to be 5 seconds. So plus what is to be the acceleration, and our acceleration is to be negative 9.81 meters per second squared divided by 2 times, of course, time squared. And our time squared is to be 5 second squared. So with that, we can now solve for the value for our Vi. So rearranging this equation, so Vi is to be equal to negative 30 plus, so if I am to move this to the other side of the equation, so this would become positive, so plus 9.81 divided by 2 times 5 squared, of course, divided by 5 to get rid of this constant here. So with that, Vi is now to be equal to, looking at the calculator to our left, negative 30 plus 9.81 divided by 2 times 5 squared divided by 5, and my answer here is to be 18.525. So 18.525 meters per second, and as you can see, it is to be positive because it is going upwards. So if your answer here is negative, then there is something wrong with your solution or your equation. So that is to be for our letter A. Okay, so once again, our answer here is to be 18.525 meters per second. So that is for letter A. So what about for letter B? So for letter B, how high does it rise above its starting point? So for letter B, so we would now be having this particular distance here. So from this point up until this point, so how high does it rise above its starting point? Okay, so once again, you can make use of any of this equation as long as it is appropriate. And in my suggestion, I suggest, of course, us making use of this formula. So why? Because we have our VF squared. So our VF squared is equal to 0, like what I have indicated earlier. So at this particular position here, the final velocity must be equal to 0 meters per second because it is on the verge of going down. So from positive velocity, it would now be converted into negative velocity. So it means that at that particular point, nandun na siya sa boundary ng positive. And that is to be 0, of course. So with that, so if I am to rewrite the equation here once again, so VF squared is equal to VI squared plus 2G y. So VF is known and this is now to be equal to 0. So for your VI, we have already solved for that earlier. So that is to be 18.525 meters per second squared plus 2. So what is to be your gravity? So this is now to be negative 9.81 meters per second squared times, of course, y. And y is to be the one unknown here. So with that, y is now to be equal to, so 18.525 squared divided by 2 times negative 9.81. So the value for y is now to be equal to, so 18.525 squared divided by 2 times negative 9.81. And my answer here, oops, I'm sorry, this should also be negative. So negative 18.525. So with that, there should also be a negative value at the top. So with that, our answer here is to be equal to 17.4911. Okay, so this is now to be the value for y. So as for C, what is its velocity 5 seconds after it leaves the thrower's hand? So this is very simple. So what we will be doing, so for VF is to be equal to VI plus GT. So simple. So with that, for VF and for VI, that is to be equal to, so 18.525. Plus, so what is to be the value for gravity? So negative 9.81 meters per second squared times time. So times time, and what is to be the time? So 5 seconds after it leaves the thrower's hand. So 5 seconds. So with that, VF is to be equal to, so 18.525 minus 9.81 times 5. So with that, the final velocity is to be negative 30.525 meters per second. So this is now to be the final velocity 5 seconds after it leaves the thrower's hands. So maybe it is to be at this particular equation. So basically, ito pala. So tumaas na siya. So tumaas na siya dito, then bumaba siya. And dahil pababa na siya, ito na yung velocity niya, yung VF niya dito, negative 30.525. Nagkataon pala na 5 seconds yung inanalyze natin for E and 5 seconds for letter C. So this is now to be our final answer.